All right, so same thing applies for gases, okay? Now there is one gas law that I kind of want you to keep in mind, and that's Dalton's law of partial pressures. Remember that partial pressures add up to total pressures. That's what his law is. P total equals P1 plus P2 plus P3 plus so on and so forth. Okay, and this is for any gas mixture. Okay, so we're actually going to get some pressures to change when we're reaching equilibrium with gases, and I want you to keep that in mind. So I'm going to do example number 13, and then you guys can try example number 14. So 13 says a flask is charged with 1.500 atmospheres of N2O4 and allowed to achieve equilibrium. Now, I didn't give you the equation, but this is the same equation that we've been using for other examples. I would have given this to you if it was a test problem. So I'm going to start setting up my ICE table here. Now I said you can use molarities or you can use pressures, right? If we're calculating Kp, we should use pressure. So I started with 1.5 atmospheres here, 1.500 atmospheres. I didn't have any of this. So I know I'm going to lose some of this. I'm going to gain some of this. So this is 1.500 minus x, and this one is 2x. All right, it says at equilibrium, the partial pressure of NO2 is 0.512 atmospheres. So I actually know this one. Right, equilibrium NO2. So I know that's 0.512. So that's pretty easy. I can calculate the X is 0.256. Great. Okay, I'm going to put units on this. I got that one. Now I can plug X back in over here, and I can get this pressure, 1.244 atmospheres. And then it says, what is the value of Kp? Easy peasy. Kp is going to be the partial pressure of NO2, right, squared, over the partial pressure of N2O4. So I can just plug in my pressures now. NO2, I said, is 0.512 atmospheres. That one needs to be squared. And this one is 1.244 atmospheres. Now it's squared. And you should get that Kp is 0.948. All right. So like I said, try example number 14. This is another good example with pressures and practicing with your ICE tables. All right, so in this particular case, I set up my equation and I had K, so I solved for X and then plugged it back in. This would have had to use the quadratic equation or the solver button on your calculator, and you should have gotten that chlorine gas is 3.84 atmospheres, and then the chlorine individual atoms gas was 1.31 atmospheres.